Okay, grade 9, last review before your Tuesday test tomorrow morning. What I'm going to do is I'm just going to go through each chapter one at a time, and I'm just going to give you 4 different questions from the chapter to kind of help you remember some of the more important things that you have to know. So here's your first chapter, chapter 1. Okay, so here we have our first 4 questions, and actually these 4 questions are what we decided were probably your most important ideas from chapter 1. So the first question says, how many lines of symmetry are there in a rectangle? Now remember, lines of symmetry are lines that when you draw them, they make a reflected image, an identical reflected image across. So you can use a mirror. In grade 7, you used mirrors to look for lines of reflection. But this point here, if I was to call this point A and this point A prime, the distance between those 2 points is perpendicular and equidistant to each other. This point here, if I was to make it B, would be equidistant and perpendicular to the line of reflection. So that would be one. That dotted line that is right here is one line of reflection. So we say there's one so far, and the only other line of reflection there would be is this one. There's 2. So the answer for this question is a rectangle has 2 lines of reflection. And some people might say, well, hold on, there's another one that goes across here. But this point here, if I was to draw it perpendicular to it, its counterpoint would have to be over here. And as we can see, the counterpoint is actually, there's a lot of lines here. Let's just go back and take some of these out. This line here. So if we talk about the line here, this point here is not perpendicular to its counterpoint, so it's not a reflected point, right? In order for it to be a reflected point, it has to be perpendicular. So the answer for this is there are 2 lines of reflection. And the second question is, what's the order of rotation and what's the angle of rotation? So remember, an order of rotation is if you rotate it 360 degrees, how many times does it appear as itself as it started? So as I rotate this, halfway through the rotation it appears as itself, and a full rotation it appears as itself again. So the order of rotation, we say, is the number 2. It's order of rotation 2. And the angle of rotation is determined by taking a full rotation, which is 360 degrees, and dividing it by whatever the order of rotation is, in this case 2. And that means the order, or the angle of rotation will be 2. Now what does that mean? That means when I rotated that through this, I had to rotate it 180 degrees until I saw it itself as itself again. And then another 180 degrees and it appears as itself again. So the order of rotation is 2 and the angle of rotation is 180. In the third question, you have a solid rectangular prism that is 10 by 20 by 10. And the other one over here has a chunk taken out of it, like a step. So if I use the green here, this 10, this part here, and this part here, if we were to think about those 2 together, would have the same surface area as this here, because you can kind of bring this face forward to meet up with that. I would make a complete face that would be 10 centimeters high and 10 centimeters wide, or 100 square centimeters. This top face, which is red, if I combine this one with this one, I would have the exact same size as the top one here. But if we look at this side one, this blue one here, there is no other part to go with it that would make this full blue face here. So the answer for this question is, which one has more surface area? This one here has more surface area than this one. This one loses surface area when it's in the step, and we said that the right way to remember that is it's a step down in surface area. But the second question is a very poorly drawn one with a little notch taken out. And if I was to take my marker again, this green part here with what should be right there, if I put those 2 parts together, we can kind of see that completing the same size face as would be in a solid one. And if I take this blue one here and say this blue one here, plus this blue one here, those 2 together would be the same surface area as the back of it. And this red one on top, this part here, plus this part here, would form a complete face of the top, which would be the same as the bottom. So in this case, if it's a notch taken out, it has the same surface area as if it didn't have anything taken out at all. In chapter 2, so these 4 questions would be typical questions you might see on your exam, okay? So the first question says, which is greater in value, which value is greater than -1 and 5/6? So if I take this question, I have 4 choices, A, B, C, and D. So the first thing I probably want to do is I want to decide on which method I want to compare them. They either have to be all fractions or all decimals. Now, if they're going to be all fractions, the problem with that is they have to have a common denominator. Otherwise, you can't figure out which one is greater, so you have to change them all to equivalent fractions with the same denominator. So the easiest way to do this is to simply convert all of these to decimals. So as a decimal, this is going to be negative 1 and whatever 5/6 is. So if I grab my calculator, oh, that's not a calculator. Hang on a second. My calculator's here. I go, what is 5? Oh, bring it over here. 5 divided by 6. And it tells me decimal 83 repeating. So this is exactly the same thing as this. Okay. So obviously I can eliminate C as my answer because that is the exact same thing and it's not greater. Then I have to look, well, on a line, on a number line, if I put 0 here, negative 1 here, negative 2 here, the farther something is from 0, the greater it is. The farther it is from 0, the greater it is. So negative 1 decimal 8 repeating is actually negative 1 decimal 888, which is farther than, this is negative 1 decimal 888, which is farther than negative 1 decimal 83. So it's actually smaller because the farther away it is, the smaller it is. So we know that A is not the answer because the farther away a number is from 0, the greater it is. So then I'd say, well, it's either B or D. Now I know that negative 1 and 4/5 is the same thing as negative 1 and 8/10, which is the same thing as 1 decimal 8, which of course would be slightly closer to 0, and therefore is greater because as a negative number, the closer something is to 0, the greater it is. Our second question says, which is a fraction between negative 0.34 and negative 3.6? So if I go to that question here, if you're given one of these questions, the first thing you want to do is probably decide on a decimal that is actually between there. So, and we'll do this question, then we'll do a different one here. So the first thing I'm going to do is I say, well, I know that this number right here is going to be midway between there. So if I was to figure out this one, I could then be able to determine if it was a multiple choice. This is going to be midway between the two. But all we want to really do here is take all of these fractions and convert them to decimals themselves, and then we'll look at them and see which ones are between there. So for A, 17 divided by 30 is 0.566. Is that right? Yeah. 0.56 repeating. So that one is not between these two, so I can eliminate C. For B, 9/25. Now I can just make this an equivalent fraction out of 100, which would be times 4 and times 4. That would be negative 36 over 100, which is a decimal, is negative 0.36, which of course is not between there. It's exactly one of the posts, so it's not B. For this one, you could do change this to a decimal. So instead of using equivalent fractions, I'm going to take my calculator again and say, what is 7 divided by 20? And it should be 3.35, which it is. So 0.35. And 0.35 was what I said before would probably be midway between it, which happened to be the exact answer of C. So we know that it is midway between the two, and therefore your answer would be C for that one. Your next question said, which is not a perfect square? Now, it's easy to do a perfect square when you have a calculator, because all you have to do is say, is this a perfect square here? If I want to say, is B a perfect square? Take my calculator and go decimal 1/6. And if it is a perfect square, if you square root it, it will give you a terminating decimal or a repeating decimal. In this case, it gives you a terminating decimal. So this is a perfect square. So we can't have that because it says what is not a perfect square. 1/25. If it's in fraction form, that's the easiest. So what fraction multiplied by itself gives you 1/25? So if it's a perfect square, 1 times 1 is 1, and 5 times 5. So what is the square root of 1/25? The square root of 1/25 is a fifth. And therefore, it is a perfect square as well, which means that can't be included in my not a perfect square. Now, if you have a mixed fraction like 30 and a quarter, you cannot do the same process that we did down here. Instead, what you have to do is change that to an improper fraction. So 30 and a quarter is the same thing as 121/4. And then if I repeat that same procedure, what fraction times itself is 121/4? I get 11 as my numerator. I get 2 as my denominator, and therefore the square root of that would be 11 halves or 5 1/2. So it's a perfect square. So we know for a fact that the answer is C, decimal 9. If I want to make sure, I take my thing here and I say, well, I know that 9 is a perfect square because 3 times 3, so it seems reasonable. This should be decimal 3. But when I square root it, it actually does not come out as that, so it's definitely not a perfect square. But 0.09 is a perfect square because it's 9 hundredths. And what fraction multiplied by itself is 9 hundredths? It would be 3 over 10 and 3 over 10. And your final question for chapter 2 is calculate what this is. So this is doing it without a calculator. You could use a calculator if you want, but it's a little bit harder to do. So we're going to change our mixed fractions first, in my opinion, to improper. So it's going to be 9 fifths. Take away 8 thirds. Now that we have that, we find our common denominator of 15. Making our equivalent fractions, which will be 27 fifteenths and 40 fifteenths. Now this is the important step that we said on your test to write out. This is important that you write this out. 27 take away 40. Now if you can't do that in your head, you can use a calculator, and on your test that you're allowed to use a calculator. 27 take away 40. It tells you it's negative 13. So that would be your answer. However, if you don't want to use your calculator, you can keep flip change, and 40 negatives and 27 positives is still negative 13. But either way, make sure on your test you use a calculator for that part, 27 take away 40, because some people put positive 13, and it probably will be a choice on your test, and you'll probably get it wrong. Okay, chapter 3. So for this one, what we're going to do is just do 4 true or false questions. And the first question says, in brackets, negative 2 squared is the same thing or is equal to negative 2 without brackets squared. And the answer for this is actually, you ready for it? True. However, most people would probably put false in this case, because what I want to make sure you understand is that this is not the same as this, and it's not the same as this either, or this here. So when you have it in brackets, the negative 2 is being defined as the base. So here, because the exponent is not outside the brackets, it's only touching the 2. That means that this means, if I was to read it, I would say the opposite of 2 squared. And the opposite of 2 squared, since 2 squared is 4, the opposite of this would be negative 4. This one here, since there's no brackets around it, this also says the opposite of 2 squared, which would be negative 4 as well. Now keep in mind that when the bracket is outside the brackets, so the exponent, excuse me, is outside the brackets, this means that this is your whole base, and it's going to be put to the exponent of 2, which means in repeated multiplication, it's negative 2 times negative 2, which would be a positive 4. Now, of course, there are people who are like, oh my God, I forgot totally about that. But that is how we have to approach negative 2 squared. In the second question, we have negative 3 to the exponent of 0, or the negative version of 3 to the 0 is equal to 1. And again, this one, believe it or not, is false, and here's why. If you have a base defined like this, negative 3, that's your base, and you put brackets around it and define it as the base, and put it to 0, then it is equal to 1, a positive 1. Anything, any base, it doesn't matter what it is, it could be a McHappy Meal to the exponent of 0, it will always have a standard form value of 1. However, if there are no brackets around the negative 3, the base is still just 3, and it's the opposite of 3 to the 0. Since, if I take this negative sign and erase it for a second, since that would have a standard form of 1, then this would have the opposite of that value, which would make it a negative 1 instead of a positive 1. In the next example, we have our exponent rule. So 2 cubed times 2 to the 4th equals 2 to the 12th. And in this case, your rule is if you are multiplying like bases with different exponents, your rule is to keep the base and add your exponents, which means in standard form, it should be 2 to the exponent of 7. Now, 2 cubed is really 2 times 2 times 2. That's what 2 cubed is. Multiplied by 2 to the 4th, which is 2 times 2 times 2 times 2. And as we can see, we really have 1, 2, 3, 4, 5, 6, 7 2's multiplied together, which means this is your standard form. So the answer for this question would be false. It is not 2 to the 12th, it is 2 to the 7th. However, in the next question, 2 to the 4th cubed, we have an exponent to an exponent. And what this means is 2 to the 4th is being multiplied by itself 3 times. So 1, 2, and 3. And again, we're going to follow this rule. When you have like bases to exponents, you keep your base and add your exponents. So 4 plus 4 plus 4 is 12. So therefore, that is your answer. And the answer for question 4 in chapter 3 is true. For chapter 4, the two things you need to remember are just these two things. And I don't think I'm going to go over many of the questions here because I think for the most part we have a good understanding. But I'm going to go through scale factor. So if I said to you that a diagram of a blue whale, and I'm going to draw a really nice blue whale. There's a blue whale. And the drawing of the blue whale I had was, let's make him, this looks to be about 28 centimeters long. So if the drawing of the blue whale was 28 centimeters long, and the scale factor used to draw him, I say the scale factor was 0.0001. I think that's right, maybe. Meaning the scale factor. So that's what I multiplied the actual blue whale by, his actual length by, to get this drawing. So what we have to do first, since this is the drawing, this is not the actual blue whale. You can put the D there. And the actual blue whale, we'll have to figure out what it is. So if I take my actual blue whale, which I don't know, X, and I multiplied it by the scale factor of 0.0001. I think I might have one extra zero there, I'm not sure. I would have gotten the diagram. Oh, let me just do this a different way. Sorry. Let me substitute this in. So D is 28 centimeters divided by the actual, which I don't know. So I'm going to put divided by X equals the scale factor of 0.0001. So 28 over X equals 0.001. So algebraically, the first thing I'm going to do is multiply both sides by X. That's going to be 28 is equal to 0.0001x. Now I'm going to divide both sides by 0.0010 and 0.0001, and hopefully I did this right. I think I might have an extra zero there, but whatever. Oops. So 28 divided by 0.0001 equals, oh, I did that wrong. Oh well, he's a big whale. Equals 280,000 equals X. So the actual blue whale would be 280,000 centimeters. Now, since there's 100 centimeters in a meter, oh, I did this so wrong. I was 2 zeros extra. Then the actual whale would be 280 meters long. Oops. But anyway, you get the idea. That was a bad example. Forget that example altogether. Ignore that. Purge that from your memory. Just remember you got to put your D and your A in, and you'll be able to figure it out. So D would be 28 divided by the scale factor, which I should have made into this number here. So divided by X, or X equals the scale factor of 0.01. Okay, there you go. All right, purge that from your memory. Let's go on to the next chapter, or the next part on proportional reasoning. So, proportional reasoning. If I was to give you a triangle, and I was to then enlarge it, and I was going to clone it, and bring it over here, and grab it, and make it larger, and I was to tell you that these two triangles, ABC and DEF, are similar. So ABC is similar to DEF, and I was to give you this is A, and this is B, and this is a C, and this is a D, and this is an E, and this is an F. Well, because they're similar, they have proportional sides, lengths, and they have equal angles that are corresponding. So if I was to tell you this is 2, and this is 3, and this is 4, and I was to tell you this is 10, and this is X, then you should be able to use proportional reasoning to figure out how big they were. So I'm going to call this one the one I don't know. I'm going to call the actual triangle as all the sides I know. And the diagram is going to be this enlargement over here. So D over A is going to be how we set this up. So if I wanted to figure out the scale factor, I could say 10 divided by its corresponding side, so 10 and 2, means the scale factor would have been multiplying everything in my original by 5. Okay, that's the first thing I could, or everything in my actual by 5. So because that's true, I would know that this side over here is 15, and this side over here is 20. So that's one way to figure out missing side lengths is to use scale factor. But another way you could do it is to simply use proportional reasoning. 10 to 2. So this side to this side is proportional to its corresponding missing side to this side. And when you set it up like this, remember you can cross multiply this way to give you 2x, cross multiply the other way to give you 40. Isolate the variable, and x will equal 20. So you can solve it a different way, but you get the same answer. Okay, I got to be honest with you. My classroom is roasting. According to the thermostat, it's 33 degrees in here, and I am dying. So what I'm going to do is just encourage you, tell you what, go back through the videos, find some questions from previous chapters. There's all kinds of them available. Look through some of them, press pause, try the questions, listen to the explanations, because the questions that we did during each of the chapters are going to be the same types of questions you're going to see on your exam. Hopefully this helped you a little bit. And tomorrow morning, I will be in the room with you. So if you have any further questions before the exam begins, make sure you ask. I'll be available for you from 8:15 on till 9 o'clock when the exam starts. So make sure you have your questions for me, and I'll help you as much as I can. Good luck to everybody tomorrow.